Hi, I'm Stephen Moore with Cisco's Customer Proof of Concept Lab in Research Triangle Park, North Carolina. In this epoch, we build and test customers' network topologies to provide them with real, true runtime on their custom network design. We're going to take a look at the new ISR 4451X series router and provide an overview of how to measure system processor utilization. With the introduction of the ISR 4451X router and its new architecture, we need to change how we think about the system compute resources and therefore also how we monitor and measure them. The 4451X runs iOS XE, which also changes how we interact with the device. For traditional ISR routers running iOS Classic, there is but one processor, and iOS has complete access to it for executing the integrated control and data plane of the system. With a single CPU and monolithic operating system, it is simple to characterize the processor utilization with one command, show process CPU. This command is well known to operators familiar with iOS, and so we won't look at it any further. On the other hand, the ISR 4451X runs iOS XE and has several key components to the device. Understanding each of them and the role they play is helpful as one seeks to measure the processor load. We'll look at each of them, describing them, and then showing some commands that will help us dig a little deeper. The first key difference between the 4451X and traditional ISRs is that there are separate processor resources for the control plane and data or forwarding plane of this device, so we have to measure them independently of one another. The next key differentiator is that the 4451X is running Cisco's iOS XE operating system. As iOS XE is based off of Linux, the kernel owns all the control plane processing resources via the scheduler, and every other piece merely contributes to the entirety of the system utilization. Because access to the Linux portion of the system is protected, we'll look at each of the pieces individually to understand how they contribute to the whole. As mentioned previously, iOS XE is based off of Linux, and so like any Linux system, there is a kernel which performs the traditional functions, roles, and responsibilities of an operating system. Most pertinent to our topic today would be the scheduler. From the perspective of the kernel, everything is a task to be scheduled, and thus it encompasses the complete view of the control plane utilization. Everything runs under the supervision of the scheduler and contributes its part to the whole. To view the total system load, one may issue the show platform software process list RP active summary command, focusing on the section which is titled load average. This section of information is located at the end of the command output and provides a high-level overview of the total system load. This should account for all the control plane tasks running in the system, such as IOSD, for example. It is possible to list all the processes running by issuing the iOS command show platform software process list RP active. This, in theory, provides a list of the tasks from the perspective of the Linux kernel of iOS XE running on the dedicated control plane processor. For a very simple summary view of the total CPU utilization of the control plane system, one may issue the command show platform software status control-processor brief. This gives a per-core idle percentage value and some historical utilization data alongside memory utilization statistics. As IOSD is a process running inside Linux, if one issues the very familiar show process CPU command, it will not show the total system utilization. Rather, only the load of the processes and threads from within IOSD. In other words, if something outside of IOSD is creating a load on the CPU, show proc CPU could quite possibly display no utilization at all. This is probably the most essential conceptual departure from the traditional ISR platforms that will significantly impact how you operate and troubleshoot your device. If you wish to see how often IOSD is run, you can do so via the command show platform software process list RP active name IOSD. It is very important to note that there are more descriptive and helpful commands currently being developed to help the operator better understand how each piece of the system contributes to the overall system load. Another new functionality introduced on the ISR 4451X is that of a virtual service. A virtual service is essentially a virtual machine of one type or another running inside of the Linux portion of the 4451X. The charter virtual service available on the 4451X is ISR WAS, for example. To view how much of the total control plane processing power the virtual service is consuming, the operator may issue the show virtual service utilization command and reference the name given to the virtual service upon installation. The forwarding functionality of the ISR 4451X, also known as the data plane, resides on a different processor in the system, providing significant increases in packet processing functionality. To see how utilized the data plane is, the operator may issue the CLI command show platform hardware QFP active data path utilization and refer to the last line of output where the processing load percentage is displayed as a moving average for various time intervals. In summary, traditional ISR systems running iOS Classic OS require the use of only one command to view the composite processing load of the system for both control and packet processing. The advanced functionality of the ISR 4451X requires a different architecture and thus must be treated differently. They are separate control and data plane processors, each with their own commands to gather and display their respective data for each. Each piece of the system should be considered independently. As previously noted, further information to help make this process easier is currently being worked on by development. We hope you have found this information to be helpful. Come visit us in the CPOC where today you can test drive your network of tomorrow. Thank you.